My name is Jeremy Oxmacher, and this talk is on building a modern software factory leveraging DevSecOps. So a quick disclaimer and an aspiration. At its best, this talk is informational. So that basically means that don't go change your 401k allocations based on anything I say here, or do, but don't blame me if it goes wrong. So here's what we're going to cover. We'll cover what a modern software factory is. We'll talk about how it's different from traditional IT and how we are building our modern software factory. I'll tell you who we is in just a second. And, go back. There we go. And we'll talk about some of the challenges involved in building a modern software factory. So, as I said before, my name is Jeremy, and I am an IT solutions architect in CA's internal IT department. So we have a diverse and global IT footprint, and we are 3 years into our adoption of agile methodologies. And as an IT department, our primary customers are CA employees. So the products and solutions we deliver are to CA employees, and by enabling them, they are able to deliver value to you, our true customers. So what is a software factory? This image of car manufacturing, this image of car manufacturing is really a good start to understanding what a modern software factory is. If you think about the assembly line continuous production that automotive factories use to build their products, that's a start of a conceptual foundation. And that's in opposition to sort of batch production of goods like you'd have in a bakery, where you have to take every part of the product that you're delivering all the way through step one before you begin step two. However, unlike car manufacturing, we're not building the same software over and over again, but we are building the same categories of software over and over again. We're delivering a category of Java web applications over and over, or of an interface and integration using the Python programming language again and again. Or we're using a packaged application. We're taking packaged applications that come from some commercial vendor that come in Docker containers, and we're deploying those things over and over again. Or if you take an example from the infrastructure side of the house, building server templates, we do those things over and over again. So these are the kinds of things that we have in our manufacturing process. And what you really need is a way to not do this in bulk, but to take it one user story, one feature, and one capability at a time through your process. And the modern software factory is essentially the process and tooling that enables us to do that in a way that's resilient to change. So we want to be able to be delivering value, delivering products to our customers, to CA employees, in a way that allows us to adjust to changing conditions. So can anyone think of a particular change that might cause you to pivot as you're delivering a project? Anyone? A deadline? Yeah, maybe you'll cut some features, or change the scope. Sure. Anything else? Maybe an internal or external change that could cause you to pivot? Maybe a reorganization or reprioritization of your business's goals. Maybe there's a change in the market, a shift in the market, or new regulatory requirements. So you want your software factory to be able to be resilient to these changes, to take the ideas that you have and come up with a relevant outcome regardless of what happens along the way through this iterative development. I'm pretty sure you've seen this slide a few times, so I won't belabor it. But just to say again, the products that we're delivering are to our CA employees in internal IT. And I think Mike and Ayman and Otto covered pretty well the essential ingredients here of agility, automation, insights, and security. I will say, when you think of a factory itself and that factory metaphor for the modern software factory, what is it that makes it modern? There's really one thing that makes an automotive factory modern, and it's one word: automation, right? Without automation, we just have an assembly line and humans doing the same thing over and over again. repeating the same processes, which is something that people aren't really good at, but machines are. So let's talk a little bit about how this paradigm, how the modern software factory that we're building in CA's IT department is different from traditional models. And I want to start with a simple assertion. And that assertion is that you and I can't deliver the quality and speed that we want to our customers using the old methods that we've used, using the old methodologies and processes. Agree, disagree? Agreed. Why is that? What's different? If you think about it, it's really, there's one thing, it's change, the accelerated pace of change. And the technology that enables that change, the network effects that enable that change to propagate and hit us faster and cause us to need to shift to adjust to these changes. So if we take kind of a remix on that agility, automation, insights, and security, and talk about the before and after for our IT department. In our production, we had a batch production process, so I'm still using manufacturing terminology here, but really what I'm talking about is waterfall. And I can give you a personal example of a project I was on 5 years ago where we had a really long requirements analysis phase, a really long engineering phase, a really long test phase during which they found a bunch of errors, and then we spun up the engineering team again, and they had to do all that rework. And so these big handoffs of the whole product from team to team is error prone and slow. By not having that close collaboration on each piece, there's miscommunication. And so as we've adopted Agile and have gone to a situation where we're delivering user stories and sprint by sprint delivering features, that has enabled us to move much quicker and to get value sooner. In a batch production process, like that bakery example I gave you before, when the batter's made, I can't eat the cupcake. The batter's made, it's not like I'm going to scoop a handful of batter out because it has to make it all the way through the process. But in our modern software factory, basically, when something comes out the end of the factory assembly line, that's ready to be used by our customers. When we talk about process, we're really talking about testing and release processes as it relates to delivering value to our customers. And so in the past, a great deal of this would be documented. We have long requirements documents, long manual tests, and long Excel spreadsheets with release processes that someone would go step by step down through. And one of the things that this requires is you have no choice as to whether or not you have a manual approval gate. If you have a manual test and release process, you need a manual approval gate to validate that the people did what they say they did. Whereas if you move to an automated testing and automated release process, you at least can decide based on regulatory requirements, non-technical aspects, as to whether or not you want to have a manual approval gate like a change advisory board before you move things to production. When we think about insights as an IT department, we think about the operation of the applications that we're using. So, in an IT department, we have access to the customer. We know who the customers are. We have relationships with them to determine what work we're doing. So we can go and talk to them to get insights into what they need next. But we don't go and talk to them to see how the system is running, to see how it's operating, to see if it's performing to the specifications that they asked for, because we need to know that information beforehand. And in the past, we would have sort of manual efforts every time we wanted to get some insights. Go collect a bunch of logs, analyze them. Let's hope we still have the logs from the past so we can see if we've moved the needle in terms of providing customer experience. And then finally, on the security aspect, I think you can guess in the past who was responsible for security. It was the security team, and it was supplemental to everyone else. So the only place that anyone would come into contact with the security team was when they were finally ready to move to production. There would be a vulnerability scan that happened at that point. And so based on this long batch production process, that system that's getting a vulnerability scan before moving to production, it may have been on the network for a year or 6 months before someone finally said, oh, well, now you want to go production, now people are going to use it, now we should vulnerability scan it. It's been sitting there all along, vulnerable to the things that it was. So if we zoom into the security pieces, because this is a DevSecOps talk, really what we're talking about is moving the security scanning earlier in the process. And so as we've built out our modern software factory and began to run our products, our internally built solutions through automated static analysis, I can tell you, one brief example of an application that we ran through where we found 10 critical vulnerabilities on the first scan. And this is an application that had been in production for years. And we found these vulnerabilities, and the team that developed this application, they didn't know that these vulnerabilities existed. They weren't aware of that kind of level of security knowledge, but by using an automated static analysis tool, they're able to increase their skills and prevent introducing those kind of bugs in the future. I won't go through piece by piece here, but this is sort of a capability model for the capabilities that we've put into our software factory around each aspect of plan, develop, test, release, and operate. And so, for a long time we had just the dynamic security component, which would periodically scan our production subnets. You would have vulnerabilities found, and then we would open a ticket for someone to resolve it. And the challenge there is that then you have to have some process for ensuring that people actually can close those vulnerabilities. And these things are being found after the project team for that piece of software has already disbanded. So who do you go to get that vulnerability resolved? By moving it earlier in the process, we're able to have the team, have the insight, have the knowledge, address that incident sooner. The other thing that I don't have on this slide, which is kind of our new way of thinking about security in the IT department, is something that Deb Danielson kind of talked about in the keynote this morning, where she was saying, to do security, you have to get everything right. And the attacker only has to find one thing that you've done wrong to get in. So traditionally, the network is the perimeter. You want to have a really strong firewall, and maybe you segment your network inside so that you can block an attacker if they get through one level. But we really see identity as an additional really important perimeter in the event that the network was breached. And the reason I say that is that we're in the world of public cloud now. Public cloud is here, and we have multiple public cloud accounts that are connected to our CA internal network. And so there are a bunch of different teams within CA that have their own public cloud accounts, and the network is directly linked. So it would be pretty easy, for them to do something wrong and have an attacker get inside our network. And so having the identity as an additional perimeter is really important. And when I talk about that, I'm talking about 3 different kinds of identity. I'm talking about external identity, which is how users access applications through single sign-on. So that's one layer. And then there's privileged identity, which is how our system admins and application admins access their application with high privilege, and being able to have the proper hygiene around privileged identity so that we are rotating those keys periodically and only the right people have access to them. We're able to audit when the privileged access is used. And then the third piece, which is really new to us, is application identity. And this is, again, ensuring that application components are authenticating and having hygiene around the way that they authenticate with each other and with other systems. So being able to say that server X, Y, and Z perform the app tier role in this application, and if they want to communicate with the database, it's their identity as that role that allows them to retrieve credentials that let them do that, and those credentials are rotated automatically. So we don't have teams of people knowing generic credentials and passwords that don't change for long periods of time because they're used in production applications. So building a modern software factory is not all sunshine, rainbows, smartwatches, and skateboards. there are obviously significant challenges to moving from these old models to the new models. And first and foremost is organizational transformation. If you want to do significant change in an organization, there are a lot of things that you need to get right. You need to have vision. You need to have the skills within your organization. You need to set the incentives right. You need to give people the resources they need, and you need a tactical plan, the actual steps that you're going to execute. And if you get any one of these things wrong, you end up with confusion or anxiety or resistance or frustration or false starts. So this is the big challenge of evolving and building a modern software factory for your organization. It's what we find within our IT department. The other thing, there was a computer scientist named Melvin Conway who said this thing which became known as Conway's Law, and it's basically that any organization that designs a system will produce a design that matches the communication structures of that organization. So essentially that means that if you're going to automate, that doesn't mean you don't have to communicate and collaborate. In fact, there's an increased need for communication and collaboration if you're going to automate these processes that span different functional teams. And by having that increased communication, you will be able to produce a design that doesn't involve 5 emails and manual approvals and, oh, we got the requirements wrong because we didn't talk to people. Know your customer, know your peer, and have that communication to drive the collaboration. Making security a primary priority of your organization requires focus. And I think that kind of comes into the organizational transformation as well. I think a big part of security in our organization was incentives. So incentives can be positive incentives or negative incentives. And in the case of security, it's pretty much an understood rule in our organization that if you are someone who's responsible for a breach, that's probably going to be the end of you around here. So make sure that you are diligent in what you do and know the right things that you should be doing to secure your applications and systems. So, what are the key takeaways? And I don't know if I'm early or late because we got a late start and I didn't start my timer, but the key things I want to leave you with here are getting an understanding of where you are today. In our journey, in those 4 essential ingredients of agility, automation, insights, and security, I would say we're doing great on agility, we're doing great on security. On the automation front, we've done a lot of work in terms of automating our own internal processes, but we haven't automated the delivery of solutions to our customers. And so we've probably saved over $1 million in man hours by automating the things that the service desk did manually, or the network team, or the platform team. But the actual delivery of applications is an area of focus, and one that some teams within our department are ahead of, but it's one that is actually our primary target right now. So if you take that assessment, figure out what your goal is, and from your goal, that's how you determine your scope. It doesn't work the other way around. The other thing is that you need to have a customer who's saying, I want this, because you're not Kevin Costner and this isn't Field of Dreams, right? If you build it, they're not going to come. You need a customer who's saying, this is what I want, and so that you can say, all right, we're going to build it, we're going to work together piecewise, we're going to give you the software factory to deliver solutions to your team. This is all about resources, because skills are required to adapt to this new paradigm. So you need to invest in your people and ensure that you provide a solid training plan, resources, and tools so that they can get up to speed, so they understand testing is important. Testing changes before they go into production in an automated way is important, so that we can move to a more rapid release cycle. So there was a survey by a group called Poneman, and basically they said that the average cost of a data breach in 2016 was $37 million. So you've got a big downside to not doing security and a big upside to doing security. You know, and if you look at that, it's not just like, oh, well, if we do security, we'll make our management happy because they told us. You know, it's that loss of you know, financial and industry status that will happen if you don't do it. So you ignore it at your peril. And this is definitely something that has to come from the management level, because it is something that you know, people will say, what am I going to get out of it? What is my incentive? You know, and having a positive incentive for security would be good, but it's difficult to track in that way. So when it comes from the management and said, this is one of our top 3 priorities, you know, you end up achieving a lot more traction a lot more quickly. So there's another session. The next session is reducing enterprise risk with DevSecOps. So I recommend you stick around for that. And thank you. Are there any questions? Questions? No? All right. Thank you.